All right, there's a lot of small details that makes this particular problem difficult. All in all, though, it's not that difficult of a question, but let's go through it. A square field measured 10 by 10 meters. 10 students each mark off a randomly selected region. Each region is a square and has side lengths of 1 meter with no regions overlapping. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface, blah, blah, blah. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? Okay, beneath the ground surface of the entire field. Well, what we see here is that each of these regions is representing a 1 by 1 here. So that's a square area of uno. And we know that the entire field is 10 by 10, which gives us an entire area of 100. And what we can see here is if we look at each of these, if we get the averages of all of these values, what we see is that the average, if you add them all up together and divide it by 10, you end up with an average of 150 for each of these squares. So we can all right, so every time you get one of these squares, we will get, 150 in each of those squares, like earthworms. Well, we know that the area is only 1 here, and that's 100 times smaller than what we already have. So that's actually going to turn out to get from 1 square to fill up the entire plot, that area has to be multiplied by 100, which means that we get our 150 worms, multiply that by 100, and then you end up with 15000, and that is C. 150. I'm one of those that you know what? I'm gonna multiply it and make sure that I got it right, even if it seems simple, just to make sure I get it right.